So, all right, so these are our first two examples. Starting off with one that's just a simple two-step equation. This is my variable right here, and I want to get it all by itself. And so I'm not sure it's ever been presented this way, but we know the order in which to solve an equation because it is the reverse of the order of operations. So when we were doing the order of operations, we did grouping, then exponents, then multiplication and division, and then addition and subtraction. So when we're solving an equation, we're undoing all that math. So we're actually starting at the bottom and we're working our way up. So if anything is added or subtracted to the variable, I'm going to move that first. So in this case, it's this minus 10. And I always do the inverse operation so that it takes that term away from that side where the variable is and moves it over to the other. So since that's minus 10, I'm going to add 10 to both sides because minus 10 is the same thing as negative 10. So negative 10 plus 10, that cancels out. That's 0. 25 plus 10 becomes 35. And now I'm just left with 5x equals 35. So now I need to undo the multiplication. The inverse of multiplication is division, so I'm dividing both sides by 5. 5 divided by 5 is 1, so that's canceled out. X is all by itself and equal to 7. So in this case, I have one solution. That one solution is that x is equal to 7. 7 is the one and only value that if I were to plug it back into the original equation would make that equation balanced. If I tried to plug any other value in to this original equation up here, I would not get two sides that are equal to each other. In our next example, this is where you're going to hear me a lot of times say, take a moment and look at the problem. Look at what you have here, because I'm going to notice in this equation that I have variables on both sides. And so the first thing I need to address is how to get those two variables on the same side of the equation. It doesn't matter which term I move, but there are going to be times where you're going to find that moving one is easier than the other. So they're both positive, so in either case, I would move them with subtraction. But if I subtract 3x from both sides, I'm going to end up with a negative x term over here. It's not wrong, it's just going to give us an extra step. Whereas if I subtract the 2x from both sides, I'm going to end up with a positive x term, and it's going to save me some work in the end. So I'm going to choose to subtract 2x from both sides. It's going to take this 2x, it's going to move it over here and combine it with that variable so that I have only one variable term. Anything minus itself is 0, cancels out. So 2x minus 2x is gone, and I'm just left with 4 on this side. And 3x minus 2x is just x. I don't need the 1 there, and we really need to get in the habit of not putting it there. So now the only thing that is over on this side with the x is the 2. And it's a plus 2 or a positive 2. So I'm going to have to subtract it. I'm doing the opposite to move it to the other side of the equation. So 2 minus 2 is 0. That's gone, leaving x all by itself. And 4 minus 2 is 2. So x is equal to 2. So, and again, 2 is the one and only value that can go back into this original equation so that both sides of the equation are equal to each other. Our third example is another one where we have variables on both sides. And so the first thing I need to do is get my equation down to one variable term. Now, in this case, you're going to notice that they are both positive 5x. So it doesn't matter which one I try to move, I'm going to be subtracting 5x from both sides. And this is going to turn into one of those special cases because on both sides of this equation, 5x minus 5x is 0. All of the variables cancel out everywhere, and all I'm left with is 9 equals 9. This is a true statement. Those two values are the same. And so this is a case where my solution is infinitely many solutions. And yes, you do need to write that out. I know it seems a little bit long, but I think you guys can handle it because you're not going to have to do it that many times. The other way that you could write this is to write all real numbers and use that symbol for real numbers. But again, just to explain it a little bit more, it doesn't because the two sides of the equation are actually pretty much the same thing, just rearranged. It doesn't matter what number you plug in for x, this equation will always be balanced. So it's any number, it's all real numbers, or there's an infinite number of solutions. So that's what those two things mean. You would not write infinitely many solutions and all real numbers. You would pick which phrasing you want. All right, fourth example. I want you guys to try this one. And when you have your solution, I want you to type it into the answer box. So pay attention to the fact that you do have variables on both sides and see what you can come up with. All right, so here's all of my work. Hopefully you got that x was equal to -5. In your first step, you may have done things differently. You may have moved the 3x over to the other side with the -5x, and that is okay. There's no one right way. As long as you ended up with x is equal to -5 in the end, that's really all that matters. But there's the work there for you to kind of compare what you did with what I did. All right. In this next example, I am noticing that I have variables on both sides and they both happen to be 3x. So this is going to be another example of one of our special cases because regardless of which term I move, they're both positive, so I would be subtracting 3x. And again, since they have the same coefficient, I'm going to see that they cancel out on both sides. It's going to leave me with -1 is equal to -7. Well, those are not the same number. That is not true. So we can always draw this slash down through the equal sign to show that they're not equal. And so this means that there is no solution. There is no number that we could ever substitute into that equation to make the two sides equal to one another. -1 is never going to equal -7. So that is no solution. All right, we have this example and then two more on the next slide. And in these, you're going to start to see some division, and we're going to talk about how to know which way to approach it. And again, it's going to go back to our order of operations. So I'm going to copy those down again. So we have grouping, exponents, multiplication and division, and then addition and subtraction. We start at the bottom and we work our way up. And the reason why I bring this up is because it's important to note that a numerator like this is a grouping. If you want to put parentheses around it to help you remember that, you can. So while there is a value added to my variable, it's not, the addition and subtraction is not the first thing I can do because it's within a grouping. I can't do the grouping until I do Sorry, had to pause for an announcement. Going back to what I was saying, we can't do anything that's within this numerator or within this grouping until that's the only thing we have left on that side of the equation. So that tells me that I need to get rid of this dividing by 6 first, and the opposite of division is multiplication. So I'm going to multiply both sides of the equation by 6. This dividing by 6 and multiplying by 6 cancel each other out, leaving the x plus 5 alone. 5 plus x alone. And then 6 times -1 is -6. So now I just have this 5 being added to the x. This is a positive 5. So that tells me that I need to subtract 5 from both sides. It's not actually this symbol right here that's telling me that I need to subtract. It's the fact that I need to move a positive 5, so I'm going to subtract it. Because 5 minus 5 is 0 and it's gone. That leaves the x all by itself, and -6 minus 5 is -11. So my solution here would be x is equal to -11. And it doesn't matter whether we have -11 equals x or x equals -11, those mean the same thing. All right, in this next example, it's a little different. The variable is all by itself in the numerator, so I don't have that grouping that I need to undo first to get to my variable term. So in this case, I can start with the addition and subtraction because the addition and subtraction are not in the numerator with the variable. So I'm going to start by adding 1 to both sides. So -1 plus 1 cancels out, leaving me with m divided by 9. And -2 plus 1 is -1. So now the only thing keeping my variable from being by itself is that I'm dividing by 9. So I'm going to multiply both sides by 9. These cancel out, multiplying and dividing cancel, leaving m all by itself, and negative 1 times 9 is negative 9. So that has one solution. This is our last example. I want you to try this one on your own again, and you're going to type the solution that you get into the answer box. Keep in mind that this has a grouping up here. So keep that in mind as you work through this problem to solve for n. All right, so now you can see my work and you can see my solution. Hopefully you came to the same solution. In this case, you do need to multiply both sides by negative 16 first. You don't really have any other options as far as your first step there. And then you're moving the 5 by subtracting the 5.